Hello, and welcome to the Aether version 2.1 Techinar. Thank you for joining us today. This meeting is being recorded and will be made available afterwards to everyone that registered, along with the slides. All participants have been placed on mute for the duration of the webinar, and if you'd like to ask a question, you're invited to using the Q&A module at the bottom of your screen. Following the presentations, we'll conduct a Q&A session and try to get answers to all of your questions. Now, I'd like to welcome our first speaker today from the Aether community, Scott Baker. Scott?
Thank you. Let me get the first slide up. So our agenda today is we're going to start with an overview of Aether version 2.1, our latest release. We will talk about some configuration model enhancements that went into this release. We will talk about scalability and stability fixes that we applied. We'll talk about the new complex validation rules that we support. We'll talk about how we have integrated a newer version of SD Core and the features that brings along, how to get involved with Aether, and then finally there will be time for questions and answers. Aether is built on three primary pillars: SD Core over here, which you will hear about later in this presentation, SD Fabric, which is an edge fabric solution, and SD-RAN, which is our radio area network solution. Current Aether deployments don't fully realize SD-RAN components at this time, but they do make use of the core and the fabric. At the top, we have our managed solution, which includes a runtime operational controller that supports our management portals. There's also over here in the control portion of the cloud, there is the SD Core control, which manages the SD Core at the various edge sites. And finally, a key component of Aether is that we enable AI/ML APIs and application APIs for enterprise applications. So we will talk a little bit about how enterprise applications, through this line over here, could tie in with the Aether platform to make those custom operations. Aether is inherently a system that supports multiple edge sites from a central cloud. So you can see here we have an Aether platform where we're running the SD Core control plane, as well as the AMP, the various management components. But then we have several edge sites, and the edge sites can each be independent and be controlled by that central management point. So you can have control from a single point. You can also, we've shown Aether here in a very distributed configuration. You could also do a single edge deployment where you could put the management components on the edge itself as well. Now, let me talk about the service abstraction that we present. So the primary purpose of Aether is to perform what's a conceptually simple, yet a technically complex task, and that is to connect devices to applications. So over here on the left, I've shown several devices. They could be cell phones, they could be IoT devices like cameras, they could even be industrial machinery, like industrial robotics, IoT devices, that sort of thing. And over here on the other side, I've shown various applications. These applications could be in local breakout at the edge. These applications could be in the cloud, etc. But the thing that Aether needs to do is to provide the connectivity between those two sets of things. So the way we do that is that the basic workflow is that an administrator first starts by grouping his or her devices into groups because it's easier to manage them that way. So you can see this administrator maybe took all the cell phones, put them in one group, took all the cameras, put them in another group. The slice is the abstraction we will be talking about within this Techinar that is responsible for implementing the connectivity. And then over here, we have modeling for each of these applications that the devices will use. So slice is the bridge that connects all of this together, and that'll be kind of a theme that we'll be bringing along through the presentation. Now, finally, we've taken the complexity, the complex 5G and 4G parameters, and we will abstract them to a template. And the template allows us to hide that complexity so that the operations person managing the connectivity doesn't necessarily have to be aware of all of that 4G and 5G detail. So for example, we just gave this a template, a name like the high definition video template that would connect your cameras to your DVR application, for example. Ether recognizes that analytics are as important, if not more important, than configuration control. So we include robust support for analytics. We use the popular cloud native tools of Grafana, Prometheus, Elastic. We have Grafana dashboards that would let you be able to see, the health of your deployment as well as the performance, the number of connected devices, the amount of traffic, et cetera. It's all present there in the dashboards. Now, let me talk a little bit about the modeling. So we see that same central abstraction I've highlighted in the middle, the devices, the slices, the application. But fundamental to Aether is this set of models, and they're designed in such a way that the key details that are important to the administrator form that core. So that 3 there is in the core. That's what the administrator needs to most focus on. But there are a lot of other models around the periphery that hold details necessary to support the abstraction. For example, we know that small cells, the 4G and 5G radios are necessary to provide connectivity, but the administrator doesn't often deal with small cells. Administrator most often deals with this trio of things up here. So small cells are kind of outside in the periphery. Same thing with UPFs or templates. And you can go into those objects when you need to, but we very much tried to optimize this workflow here. And then the template object is that bucket where we put those 4G and 5G specific parameters. And the template can be entirely managed by the people who set up Aether if it's in a managed service configuration, so that the administrator doesn't have to directly deal with those templates. Now, the models are available via multiple portals, a CLI and an API. So up here, you can layer whatever you want on top. Our API is public and documented, so we'll give you our own portal, a CLI, but third-party portals could easily integrate with this API. There are 2 backend stacks. So over here on the left, we have the runtime operational controller that implemented the models you saw on the previous page. It has its own API and its own subsystems, which we'll talk about a little bit later. And then on the right, we have our Grafana Prometheus stack, which does our various metrics. So we leverage Grafana as the tool to render the graphs inside of our interface so that you can get those nice Grafana graphs with the interactive control and the ability to zoom in and out of data and those sorts of features. Now, the portals, they speak to a pair of APIs for control and monitoring that are also available to other consumers. So on the previous slide, I talked about how, we have our own GUI and our own CLI, but other developers can come and implement their own controller and put it on the top and speak those same APIs that we use for our own portals. And this is how you would 5G enable a legacy application. You write this controller. This controller, in this case, it is a controller that handles video quality. So imagine that you are continuously monitoring at the UPF the latency and bandwidth of your video traffic. That could flow up. It could flow up through the metrics pipeline into the controller, and then flow down through a control pipeline back into Aether and affect the service. So this controller could be implementing a continuous loop of ensuring that the video quality is what the SLA requires, and if it's not, then adjust the QoS parameters as necessary. Okay, that was all a brief overview of Aether, and now I'm going to spend a few moments talking about some of the new features and new improvements that come with Aether 2.1. The first thing we did was to reorganize the hierarchy of models. In Aether 2.0 and below, we had a monolithic organization of models where all sites for all enterprises were available together in the same configuration database. In Aether 2.1, we've moved to one configuration target per enterprise. So rather than having a single database, it's now a collection of databases, so that in those cases where Aether is set up to manage a large number of enterprises, you can manage each of them with independent sort of backing store for your configuration. Now, this leads to smaller configuration trees since it's one configuration tree per enterprise. It leads to better performance, and it simplifies the Aether API by making the API paths less long with fewer components in the path. Even though we have divided this modeling into multiple targets, it's still possible for a single adapter to serve those multiple targets. So in here, the way I've drawn this picture, I've put a couple of enterprises under one adapter. That's perfectly fine. Whereas other enterprises under another adapter. And the multiple targets allow you to send those configuration trees down to wherever you need them for your organization. So it's still possible for that single adapter to serve multiple targets. And that means that no additional compute footprint is required in order to implement this solution. Now, we've also made several other changes to the data model. These are small but important things. So, for example, several fields in Aether 2.0, we stored them as uint64 integers, but we found out that it was actually necessary for the 5G abstraction that we be able to include leading zeros in those fields. Those fields actually should have been a text field, not an integer. So we corrected issues like that, and that facilitates some issues that we were having integrating with some of the 5G use cases. Now I'm going to talk a little bit about the configuration system. Our configuration system is called Onos config. It's depicted over here on the right. So there's an Onos config component. It's also got a store. The store is actually called Atomics, which persists the data, persists in a highly available manner. And then Onos config, it speaks the GNMI protocol out the top and out the bottom, as well as some side channels. So for this release, a lot of re-engineering and redesign went into the Onos config and Atomics components. So some of these changes began in Aether 2.0, but we haven't talked about them really until now, and then some of them are brand new. The first thing is that the controllers were re-implemented using a machine-checked formal specification language called TLA+. Now that is actually out of my specific area of expertise, but it was done by one of our developers, Jordan. And if there are any questions about how we implement the back end or how we use formal specification in order to guarantee the back end is correct, I can always forward those to Jordan. Next, we implemented new GNMI extensions to allow configurability of the GMI set and get operations. And then we updated the southbound to add support for targets that are stateless. So that was one issue we had previously, is that our adapters are generally stateless. And when an adapter would restart, it would be the case that the adapter would restart empty, and there would have to be manual intervention required in order to repush state to that adapter. Now that's all automatic now. If an adapter restarts and it's a stateless adapter, the configuration system automatically notices and automatically pushes the new state through it to configure that adapter so that you don't have any downtime where manual intervention is required. So this improves recovery times, it improves fault tolerance, and it supports cloud native adapter design. Finally, we've had some performances or some issues with stability when very large configurations are pushed via the API. We feel it's not necessary to push very large configurations. The configurations don't need to be atomic. They can always be broken down into smaller pieces. So we have implemented some checks there to vet the size of the configuration that's being pushed in via that northbound API, and as necessary, refuse things that are too large so we don't end up with those stability issues. Now, work continues on Onos config and Atomics in the future. We will be doing even more work to handle larger and larger configurations at greater scale. Finally, we've added new complex validation rule support. So typically the Yang models include very simple validators such as regular expressions for strings or min-max for integers. We support something called a must rule that uses XPaths to enforce invariance across models. For example, I've got one on here in the right, which is right out of our current modeling. And this is a must rule that validates how many device groups or how many slices a device group can participate in. Now, the syntax might appear complex to someone who's unfamiliar with it. It's just something you have to learn. But the advantage of this is a formal specification. It's not ad hoc code that's written. It is something that's formalized. It can be tested. It can be proven. And this particular rule just it's evaluated when you add a device group to a slice, and it can reject that if you try to add the device group to multiple slices from multiple sites. And these must rules, they are enforced by the API layer, and they use industry standard Yang syntax and industry standard XPath syntax. And that is what I had on the update for Aether 2.1. Now I'm going to transition to my colleague Badri, who is going to tell you about the new features that come in from SD Core 1.2.
Hi, thank you, Scott. I'll take out the screen. Yeah. I'm Badrinath from Intel. So Aether 2.1 comes with SD Core 1.2 features. We released SD Core 1.2 in October 2022. With the highlight of this release being that we wanted to move towards cloud-native 5G network functions. There was a Techinar presented on the SD Core 1.2 by Ajay, one of my colleagues. There's a link shared here. You can go through that to go through the features in detail. We released 1.2 release blogs and release notes. The links are shared here. You'll be able to access it when you have the access to the slides. We've created a different Helm chart branch for 1.2 and tagged it. So it's easy for you to download and use it. We also added SD Core 1.2 branch like for the SD Core docs. So if you want to look only at the SD Core 1.2 features, you can look at it. There is a special thank you I would like to say for all the community members from Intel, Infosys, CPQD, Purdue University, and GS Lab, and other individual contributors who have been continuously helping us and adding features and giving feedback. So let's, as I think we already know, SD Core is a fully containerized 4G and 5G services offered on it. So I'll take you through the various features we added in 1.2 to make SD Core cloud native. To start with, we'll go through the NRF Keep Alive feature. So as we started to think about enabling and scaling multiple instances of NFs, we realized that we needed NRF to track the liveness of these different NFs. So this feature does exactly that. So the different NFs, we now register as soon as they come up, they register to NRF. So now these features will help the different NFs to also send updates at a regular heartbeat interval, which we can configure. So the NFs will also send a deregister message when they gracefully shut down. So this leads to that NRF, whenever it gets all these update messages, it will update the timestamp for these various NFs. And if the NF goes down, then the timestamp for that NF would expire, and NRF would delete the profile from the DB. So when the different NFs send a discovery request to NRF, so if a particular profile is expired, so the NRF won't send that particular NRF profile in the list of discovered profiles. So along with this feature, now we see that we can also send NRF will send multiple NF profiles in the discovery responses that we send. On top of this, in future release, we want to support the NRF cache and NRF notification, which would help in that when NF wants to discover another service, it would first get it from the NRF once, and after that it can store it in its cache, and then it would get notification from NRF about if any of these cache items are already expired and those profiles are not active. Then NRF would notify, and it can revalidate its cache and again ask NRF, do a discovery to NRF again. So this is about this NRF feature, keep alive feature. So to make AMF cloud native, we had to see how to scale these AMF instances. Now, to scale an AMF instance, we had to kind of remove the connectivity component from the AMF and scale the subscriber handling part of it. So, because the G-Node-B are the ones which connect to AMF, so they need to have one single point of contact to connect to 5G core. So this SCTP-LB becomes the point of connection. It talks to all these different AMF instances and distributes the request across this AMFs in a round-robin manner. It is disabled by default, but if you want to scale up the AMF pods, you'll have to enable this in the hem charts. So you have a value to just say SCTP deploy and it will get started. So now to go through SCTP LB, what and all it does. Currently, it just reads the SCTP message and forwards it as it is. So if one of the instances receives the message for which it does not have the user access for, so let's go through this. So the first user who connects would come to SCTP LB, it go SCTP LB selects an AMF, and the AMF starts handling that user and keeps the context for that user. Now, so if there are other messages that come for this SCTP-LB, the SCTP-LB in a round-robin manner would send it to another AMF. Now, the other AMF would use this DRSM module, which I'll come to in a little bit. So it will use this DRSM module to recognize that, oh, I am not the one who handles this user. So it will redirect this message back to SCTP-LB, and SCTP-LB can forward it to the correct AMF, which is handling that user. So, so to do handling of all this, we introduced this DRSM module, which is like a distributed resource sharing module. So this module keeps track of having all the different IDs that are generated by different AMFs to be in sync, and that every AMF instance generates a unique ID. Like AMF generates IDs like the STIMC, this has the AMF UE ID, and other IDs like this. So this, so when we have multiple AMF instances, we need to make sure that each of these instances is generating its own unique ID. The DRSM helps us in doing this by syncing across all these instances and giving them unique chunks of IDs to be used by different instances. Again, SCTP-LB is disabled by default, so we can enable it when we want. To go more over the SCTP load balancer, just adding the points here. SCTP currently, it just reads the SCTP socket messages as it is and then forwards it to AMFs. In the future, we would like the SCTP to be able to decode the NGAP message and then realize which AMF ID to send it to and then send it to the correct AMF. Currently, we don't have that. So we use the redirect mechanism where we send it to any AMF instance, and the AMF would realize using the DRSM module that it needs to send, whether it is the owner of this user context or it has to send it to another AMF. In the future, we would also want to support multiple SCTP-LBs so that we can avoid single point of failure. This will also help us scale the number of G-Node-Bs that can connect to the core. Also, we would like to scale and add integration of NRF API in the SCTP-LB. So that way the NRF can track the SCTP-LB and as a custom NF. And as we start to scale the different AMF instances, we want to make them stateless so they can handle any requests that land to them. They should be, if they can't find a user context in memory, then they can go find it and fetch it from some DB. So to avail all this, we introduced storing of states for different users in AMF into DB, and we use currently MongoDB for that. So we use these various, on this completion of these various procedures like registration, service request, video session setup. For all these different procedures, once the procedures end successfully, we go and store the UE context in DB. Similarly, when the deregistration happens for any user, we would go and delete the entry for that UE from the DB. To enable testing and to keep track of, to test out the different features of this multi-instance AMF and cloud native AMF, we introduced some APIs which can be used to fetch this active UEs from the DB. And also we can purge the subscribers from AMF. And then this would help us in testing that if the AMF has purged it and you send another request to the AMF, it can go and fetch from the DB that particular context. So we can test the whole cloud native and DB fetch feature using that. Similarly, for once you have to go cloud native, we thought the next big NF that needs to have, which does most of the handling, is SMF. So to scale SMF, there are a few different approach we had to take. So it has different interfaces. So that's different approach. The SBI interface, we left it as it is. Different instances would come up. All of them would register to NRF. And so all of them can be discovered by any other NFs like PCF or AMF who is trying to discover this SMF. But on the southbound side, we need to talk to the UPF. And if we want to talk to the UPF as a single entity, then we need to introduce some kind of an abstraction layer. And that's where we introduce this UPF adapter. It intercepts this PFCP messages between SMF and UPF, and it acts as a single SMF towards the UPF. So the UPF adapter will be the one which creates the association towards the UPF, and it will maintain doing the heartbeats and keeping the link alive. So all the messages that come from these different instances, the UPF adapter will store the different IDs for them and send out the messages to UPF. And when the responses come back, the UPF adapter is responsible for sending back the responses to the correct SMF. Along with these changes for UPF adapter, there were other changes that were needed to make SMF cloud native. As we did in AMF, the SMF also does a PDU session preservation in the database. So after every procedure, like we mentioned in the AMF slide, the SMF also, after finishing the procedure, it will go store the context-related information for that subscriber in the DB. And it can fetch it if it restarts. If an SMF prod restarts, it can go and fetch it from the DB. If it already has the context, then it will continue processing that. Again, on top of that, I think the next point talks about the UPF adapter. Along with it, I think the other feature that we had introduced earlier about this NRF keep alive, the SMF also has the supporting feature to send the periodic NRF profile update towards NRF to tell that it is alive, and that keeps helping other NFs to discover this SMF. Now, as we showed in AMF, that when there are multiple instances, there is this issue of having unique ID allocation along across all these instances. Similarly, in SMF, you would have this issue of how do you allocate unique IPs across all these instances. So, because when, as per configuration, we currently configure one UEIP pool for this SD core per DNN. So for that, when you scale these instances, we need to make sure that every instance is giving a different unique IP and we are not repeating IPs. So this is again done with the help of the DRSN module, which takes care of allocating different chunks of IPs from the pool to these different instances. And if any pod dies out, the other SMF instances which are running can contact DRSM and pick up those IPs which were being shared which were used by the other pod which died. So this helps in recovery of the various other user subscribers which would come and again try to attach. On top of this, the other feature that we supported is to have a UPF supported UE address allocation. Earlier, we were only supporting this SMF UE address allocation. Now we have added configuration and the support in SMF to let the UPF allocate its own address. Along with this, now we have, if the AMF is trying to discover an SMF, and if it fails, if SMF, one of that SMF instance is down, we are adding features to detect that the SMF is down, and it can try among the other NRF profiles that the other NF profile for SMF that the NRF had given. So now the AMF can choose among them and contact the next SMF instance. Now, as part of 1.2, we added a lot of changes for GNode BSIM. GNode BSIM is our in-house testing tool which simulates GNode B and the UE. So earlier, I think if you have used GNode BSIM, we used to have different profiles in it, which would cater to the different procedures, like it would do a registration, deregistration, handover, service request. So we had like a set of 7 or 8 procedures, which was part of as part of GNode BSIM. So this is already integrated with AIB and you can use it. Now we introduced, as we started testing the various cloud native features, we needed some more support from the GNode BSIM. Like once we run certain procedures, we wanted to see if in the middle of a procedure, one of the component dies, like the SMF or AMF restarts, how does the SD core behave? So for this, we need to know that, okay, can we stop this GNode BSIM after it sends a certain set of messages, and then it can then, when we want it, it can send the next message. So for this, we introduced this custom profiles. Here you can see that we have the iteration section where it kind of tells how many iterations we want this procedure or this profile to run. And in each iteration, what we want it to run. And we also have a configuration called the step trigger, which helps us control that what part of this iteration and when it should run. So in like, just to give an example here, once we run the registration procedure, the establishment procedure, and the user data sending, this is iteration 1. So once we have run this, we would stop, the whole profile run would stop here. And this would give us a chance to go and restart some of the services if we need to. And then we can again come here and trigger the next iteration, which would again start doing service request and AN release. We also have added support for repeating certain iterations to get us more. This was kind of requested by the community that can we repeat some of the procedures and have control over it. And that's where we have introduced the repeat configuration for the different integration iterations. We also introduced the times for like the amount of time for which it will wait after running a particular procedure. That's like you can see at the end of every procedure, we've added 5 or 10, it waits for 5 seconds, and then it'll run the next procedure. So this is an example you can see on the right side is an example of the usual profiles as it is. So here we have this procedure. I think this procedure on what it runs, this profile is fixed, but in custom profile, you can change it and you can add whatever procedures you want to add in that profile. So we've also added this new feature of you can add new calls in an existing profile. Like if here you can see that the UE count is 5. So it only runs for these 5 users. So, but now on the go, you can add more user profiles to it and it'll add new calls for all these profiles also. There is a REST API to trigger new profile execution. We've added DNN and slice information configuration. In the future, we want to add more features on the GNode BSIM, which will help it to test more features out, like GNode B handovers, GNode B deployment as a container. Some of the user requests from community was to have GTPO echo handling. So some of this we've already done. We are working on it. It's already merged, but in the current SD core 1.2 release, not officially released yet. On top of this GNode BSIM, we also as part of 1.2, we added a lot of enhancements in the documentation section. This is again from valuable feedback gotten from community that there's less information on how we configure QoS, how the UPF deployment is done. There are various configuration that needs to be done for UPF. We have tried to add as much information as we can on this. We are continuously working on to improve this documentation, and we urge all of the community members to give their feedback so that we can keep improving on it. We added release notes 1.2, the different application filtering rules. So we've added the default AIB override files with comments. We've added a different design section which captures new features, design in it, and please feel free to add, give your feedback on these different sections. In the future enhancements, we would like to add more features and more documentation for the UPF deployment. We are planning to introduce a metric function which will help consolidate all the different metrics from the different NFs and be a single point of contact for any orchestrated or any app to get information from SD code. We are adding more GNodeB SIM feature extensions. Currently, whatever scaling of the pods that we saw for AMF and SMF that has been done manually, we are working towards automating this using this Kubernetes feature for horizontal pod scaling, and it would use metrics like CPU utilization, memory utilization, and custom metrics. Like I mentioned before, we are working on NRF cache and NRF notification support. And then we're also trying to work on multiple SCTP LB instance support and multiple UPF adapter support, because these are the points now after the scaling up of other instances, these become like the point of failure. So we are working on how to make them scalable and highly available. So this will be available in a future SD Core release. That's all the feature sets that I had for SD Core 1.2. Now I'll give it up for Larry, who'll take you through the next section.
Thanks, Badri. Yeah, so it's pretty clear, I think, that there's been a lot of work that it's gone into both Aether as a whole and the SD Core specifically. I want to just wrap up by talking a little bit about how we are hoping the community will get increasingly involved, and a new sort of looking forward, a new initiative that we have to try to help that process along, the process of people adopting and using and making good use of Aether. So the very fact that you're here at the Techinar probably means you know a little bit about the community, but just wanted to draw your attention to two specific things in case you've missed it. One is that you can register as an ONF member for an ONF account, and that's a way to get not only read but write access to a lot of back-end systems like Jira and Garrett and the wiki as well. And secondly, if you haven't done so already, I would encourage you to join the ONF Slack workspace. There, it focuses across all of ONF projects, but there are Aether-specific channels, an Aether dev channel. That's a great place to ask your questions and have as many possible eyes on it that can give you an answer. So that's, every community has different methods of doing things, and that Slack channel is where a lot of the work happens with Aether. If you are fairly new to Aether or don't really understand it in its full breadth and glory, I would encourage you to take a look at a couple of books that I and my colleague Bruce Davey, along with the Aether engineers, have written in the last couple of years. One of them is very new. It's about private 5G, and it's basically a survey of all the parts that go into Aether, the RAN, the core, and the management plane as well. It's a pre-release, but I encourage you to go take a look at that and speak up if there are things that you think it should include that it doesn't. Also, we drilled down in a little bit more detail on the management of Aether. It used it as an example of everything that goes into managing edge clouds. And so that operations book is a second place that you might go take a look. That all kind of leads me to the main point of this concluding section, which is, of course, we want to encourage everyone to download and run Aether. You may know Aether in a box. That has been the starting point. The problem that we've encountered is people start with Aether in a box. It's a great tool to start with, but it only takes you so far. You know, at one end of the spectrum, we have an ops team that runs Aether 24/7 as part of the Pronto project. They have a lot of know-how, and the gap between Aether in a box and how to get to a deployment of Aether that you could actually run in an operational way, even if it's in a lab, not necessarily commercially, but you could at least run it with real workloads in your lab. That step is a pretty high one. So we're working towards something called Aether on-ramp. I've got a couple of URLs back for just a second. I got a couple of URLs there, both the GitHub just to get a copy of on-ramp, and secondly, the documentation of how to use on-ramp is really a pretty important part of that. And that's now an appendix to the 5G book. So let me just next slide, talk about the on-ramp just a little bit more. The intent is that we want to take you, by name, it's an on-ramp to get you from the very first thing that you would start up into an operational deployment. Again, that's not necessarily a commercial deployment, although that would be a step beyond where we would take you, but that you could run Aether like the ops team that at ONF and Intel have done. That starts with learning about Aether, just poking around and playing and learning about all of its parts. That's, of course, very well tied to the books that go along with it. Give you the ability to develop and contribute back to Aether and check code changes in. And then ultimately, the end goal is that you can deploy and operate Aether 24/7 with real 5G workloads. The way that we're going about this, and this is now just getting started, and so this is really a call for people to participate, is a very staged progression. And you see the list here. This is not necessarily the order in which things will happen, because we may decide that some things have higher priority than others. But what exists today is basically a refactoring of Aether in a box, AIAB, just to give it a little bit more streamlined flavor so that it's easier to get from point A to B. And you see what all the subpoints are along the way. That was really the intent, is that it's not just type make everything and then it suddenly happens and then you don't know what to do next. You now know what all the incremental pieces are. And then to go back and beef up each one of those incremental parts. It's mostly done, but not quite ready for prime to release yet, is to bring in the GitOps tools that are actually part of operating Aether 24/7, as opposed to having to manually make changes to a running system. Going from emulated Gnode Bs to physical ones and multiple of them as well. Optimizing the network, so turning on SRIOV. How you connect the Aether pod to the network is really a complicated and critical part of this, because of course you have to connect the base stations back to the Kubernetes cluster. And then Aether on-ramp starts with a single physical server. Could run it in a VM. It starts with a single physical server, but you can then add servers. And then once you have it ramped up, you would also want to scale other virtual resources like slices that Scott talked about. Finally, integrating SD-RAN into Aether is sort of the final objective. And then we will have the end-to-end Aether solution for you. Everything on this list already happens. SD-RAN has been integrated with Aether. The problem is reproducing that and repeating that over and over and making it easier for everyone to do that, and not just the ones that had the engineering expertise to begin with. That's part documentation. It's part breaking down how the components fit together so that it's easy to incrementally put them back together, as far as you happen to be interested in going. You may not care to go all the way, but at least we will have hopefully a modest on-ramp that will get you as far as you'd like to go. So with that little quick overview and the URL that you'll find on the previous page, I'd encourage you to give Aether on-ramp a try. And if you've already addressed one of these issues yourself, then look for a way to fold that back into on-ramp so that others can take advantage of your experience there. And so with that, I think we're done with the presentation components. And if Scott and Badri would turn their monitors back on and maybe turn down yeah, thank you. We can get to the questions. And again, there's a Q&A place that you can submit your questions if you have any. I have a question first for Badri, and then we can come back to the one that's been posted, which is, I hadn't seen a user's manual for the simulator that you talked about, and I wondered if there was one.
There is one. I was just typing that on the screen. I think that
Yeah.
there is a section for that in the SD code document. I'll probably share a link for that on this, especially for GNodeBSIM and how you use it, and adding features to it and stuff. Yeah.
Okay, so that actually then takes me to the one of the questions that was asked, and has to do with whether you can simulate handoffs between two base stations. And so there are multiple simulators out there. Let me just ask about your simulator, and if that's a possibility there. Yes,
so we do have a handover feature in the GNodeBSIM simulator, and we have tested that, which kind of tests an intra-AM of handover. And now currently we are, I think, recently working on trying to enable running multiple GNodeBSIM in AIAB itself, so that you can kind of actually simulate handover on it. So we've currently been able to make 2 GNodeBSIMs run, but we are still to test handovers on that. So yeah, we can encourage the community to use it and give it a go.
Okay, so there's a good start there. The second thing this is a very general response, but just so everyone's aware of it, there is also a parallel to, in addition to Aether in a box, there's a parallel RAN in a box, which is the SD-RAN component that you can run on your laptop in a virtual machine. For on-ramp, I'd like to get to the point that we can connect those two together. They have been connected in trials, but we've not connected together, made it easy to do that in what's been released. That SD-RAN implementation has its own simulator, and there they do simulate handover because they have implemented XApps to do handover. So that may not answer the specific question about working with the core, but at least with the RAN, there's a second simulator that exercises that. Yeah, so just to Badri and Scott, if you could bring up the Q&A so you know what the questions are as well as I do. There is a question about, are there any updates to the Flex UPC? And maybe Badri, do you know?
Sorry, I'm not able to see the question.
The Flex UPC?
UPF, Larry.
I'm sorry, the UPF.
Right. So currently for 1.2, we didn't add any new features for Flex for the UPF. It currently supports all the necessary 5G features that are necessary, including all the QoS policing for different levels with slice level, application level, and user level QoS. In the future, we're trying to work on enabling it to be scalable, like bring out a scalable UPF. But yeah, that's still work in progress.
Okay, thanks. So there's a question, another question about MongoDB, and is it now a requirement, and how about availability? So let me start off by just saying that there already is a scalable, highly available key value store that's part of Aether broadly, and that's the Atomics key value store that underlies ONOS config. Now, I know that Badri talked about MongoDB as a backing store for the cloud native AMF, which is optional, so therefore it's not a requirement. But do you have any thoughts on how that plays out in the future?
Yes, currently we are enabling the cluster mode of it to run multiple instances and to store the information in a persistent way. At least from AIAB, we don't have an enablement of the persistent storage in it, but that's definitely what we should. It's not a requirement right now, but in future we should try to add a persistent storage on it.
Okay. Another question here. Oh, well, someone's having trouble deploying UPF. I don't know if we can do a debugging session here. Yeah, so I mean, so the question, so we've talked about Aether in a box a little bit and crashing. Basically, what's happening is Aether in a box is a great place to get started, and so you push it beyond its limits, and we all want it to do more complicated things. Yeah, and in fact, scaling up UPFs is I think a big ask as well. Multiple slices, multiple UPFs. I know it's been done, but being able to for anyone to reproduce it has been a problem. So I mean, the answer to that question is that is high on the to-do list, and anyone that has experience there and can step up and help us add it either to Ether in a box, which then can be applied to on-ramp, or just jump into on-ramp and work on it there. I don't know, Badri, or Scott, anything to add to that?
No, I don't have anything to add, Larry.
Yeah, I think definitely UPF is, I mean, it is a little complicated component to scale. It has a lot of networking components to it, which need to be managed as we scale up. But yes, currently we are trying to design all the aspects of how to scale it up. And yes, as Larry said, yes, all encourage all community members to step up and contribute even in the design phase. That would help.
Yeah, I mean, so I know Andy, who is responsible for a lot of Ether in a box, has done it. And like I said, with on-ramp, I don't think there was this thing on the list that someone hasn't done. It's just a matter of finding a way to explain how anyone can do it so that we can reproduce that. I think that is probably arguably the biggest gap in Ether right now, is that it's reproducible, and that anyone can ramp up to do all of the things that it's capable of doing. There are no other questions. I don't know if Scott or Badri, if either of you have any final thoughts or comments to conclude with. Nope.
Nope. Thank you.
You good? All right. Well, thanks for everyone for joining. And again, the video will be posted, and I would encourage you to go to join the ONF community Slack workspace and continue to ask your questions there. Thank you.
All right. Thank you.
Bye.
Yeah, thank
everyone.
you,
Bye.
and bye, everyone.